Rhombus, circumscribed, angles, this thing. It's geometry. With me, Miss Cohen.
Hi, today we are doing Unit 2, Lesson 4, and it's all about perpendicular bisectors. I goofed at the beginning. We're talking about perpendicular bisectors today. So go ahead and get that down, pause the video, and then when you're ready, turn to a new page. So please make sure you're writing today's date, whatever it is that you're watching this video. And we're in, again, Unit 2, Lesson 4, and the essential question today is what are the key ideas about perpendicular bisectors? And before we talk about the key ideas, you need to know what a perpendicular bisector is. So a perpendicular bisector cuts a segment in half, and that's what bisecting means, cuts something in half. But a perpendicular bisector does that at a 90-degree angle. So please pause the video at this point, get all this down, and then come back when you're ready. So what I want to do is draw a segment, and then we're going to draw a perpendicular bisector of that segment. So we're going to create here a line segment, and I'm going to make mine 4 units long, and that's just going to make it easy for me to bisect it. So I'm going to label my endpoints A and B. So that's a segment. And what I want to do is draw a perpendicular bisector of that segment. So the first thing that I need to do is make sure that I cut it exactly in half. And in order to do that, we need to locate the midpoint because we're cutting it in half. So the midpoint is right there. And we can mark that these two pieces are congruent. And I'm going to draw something that goes right through that midpoint. Now, if it was just a regular bisector, it could go in at a diagonal there or there, but since we're drawing a perpendicular bisector, I have to make sure that I hit this point at exactly 90 degrees. And so I'm going to go ahead and, it's real easy to do with grid paper, I'm going to go ahead and draw a line that goes through that. I'm going to label that line L. Line L is the perpendicular bisector. And I also want to take the time to show that it does hit at a 90-degree angle. So that's what a perpendicular bisector is. And today's lesson is sort of like a sleeper lesson. And what I mean by that is that even though this lesson's technically about perpendicular bisectors, it's really a Pythagorean theorem lesson because what we're going to be doing is creating right triangles and using the Pythagorean theorem to find missing lengths. So one of the properties of a perpendicular bisector, and it's not surprising if you think about it, is that I can draw a point anywhere along this line. So maybe like way out here, I can draw a point. And the distance between that point and these endpoints is going to be congruent. And that's obviously the case. You know, it was the case here, right? This was on the perpendicular bisector, and this piece is congruent to this piece. But I can also do a point anywhere else on the perpendicular bisector, and it will create congruent segments. So now this segment is congruent to that segment. And that's the case anywhere, and I hope you can see that by doing that, we've created a right triangle. So a right triangle here and a right triangle here. What else do I want to say? I could pick another point on the line. Maybe I'll pick a point closer, but maybe on the other side. And the distance between this point and the endpoints will also be congruent. So this segment will be congruent to this segment. No matter where I draw the line, it will create two, no matter where I draw the point, it will create two congruent segments. And so again, we're drawing all these right triangles. It should be noted that this segment here, the distance from A to that point of intersection, that's the shortest way I can travel from A to the line, right? The green segment and the orange segment are going to be longer, and in fact, anywhere else I go, it's going to be longer than if I go directly perpendicularly to the bisector. Okay, so using that, we are going to try to work out some problems. So these diagrams are a little tricky to draw. Do your best, and remember that you can pause the video whenever you want to. So this will be example 1. We're just going to do 2 examples today. And I'd like for you to draw a horizontal line segment and we'll label this R and T. And I drew mine to be 6 units long. It doesn't really matter how long you draw yours. We're not drawing this diagram to scale, so it doesn't matter so much. And then we are going to create a perpendicular bisector of that line segment. And so again, in order to do that, we need to locate the midpoint. Depending on how you drew yours, your midpoint might be in a slightly different spot. That's okay. And it's also okay to eyeball it because again, we're not drawing to scale. To show that that's a midpoint, I'm going to go ahead and make little tick marks. And then I'm going to draw a perpendicular bisector. So I need to make sure that I hit at exactly 90 degrees. And go ahead and give yourself a fair amount of space down here below. So this line then is a perpendicular bisector. And that means that any point I draw along the line will be create 2 congruent line segments to the end points. So we're going to do that. We're going to create a point somewhere along here. And I'm purposely going to put it in the middle because I'm actually trying not to draw this to scale. I don't want you to be able to figure out the answer just by counting. And we're going to go ahead and create line segments to the endpoints and show that those must also be congruent. And then I'm going to label some stuff for you. So first, I would like to label that this right here is 3 inches. And then I would like to label that this here is 5 inches. And I want to know a bunch of stuff, so we need to label some more points. We're going to label this S, and we're going to label this point P. And so off to the side, I'm going to list all the different values that I want you to find. So first, I would like for you to find the length of ST. I would like you to find the length of PR. I would like you to find the measure of angle RSP. And then finally, and this will be the hardest one, I would like for you to find the length of SP. So go ahead and pause if you need to get all of that down, and then we'll talk through these together. Okay, so ST is this little guy here, and this doesn't take any math at all. Hopefully you know that because we bisected it, the very first thing we did was determine that those have to be the same length. So if RS is 3 inches, then this also must be 3 inches. And whenever you learn something or figure something out on a diagram, it's a good idea to label it because the more you know, the easier the rest of the problem will be. And then PR is this guy here. And we talked about the lengths from any point on the bisector to the end points of the bisected segment are going to be congruent. So if this is 5 inches, then that also has to be 5 inches. The measure of angle RSP, we said that this is a perpendicular bisector. That means it hits at 90 degrees. And in fact, it means that all 4 of those angles are 90 degrees. The only one that's tough here is this one here, SP. So SP is this distance. And we can't just count because we didn't draw it to scale. So we're going to have to do a little bit of work to figure that out. And so we're going to use the Pythagorean theorem. I know you've learned it before, but I also know it's possible it's been a while. So what I want to do is sort of highlight a right triangle. The Pythagorean theorem allows us to find the lengths of sides of right triangles. If you know 2 of the lengths, you can find the third using the Pythagorean theorem, and that's what we have here. We know 2 of the lengths, and we need to find the third length. And that'll give us the value of SP. So we're going to take a little break from this problem, and we're going to write down the Pythagorean theorem. We're going to use this a ton this year. Pythagorean theorem. If you have any right triangle, it has 3 sides. 2 of the sides are adjacent to to that angle, and those are called the legs A and B. Those are the legs. It doesn't matter which one is A and which one is B, but they're both adjacent to the right angle. There's one side that's across from the right angle, and that will always be C. That is the hypotenuse. And it is also the longest side. If you know two of the sides, you can find the third using this theorem. It goes A squared plus B squared equals C squared. That is the Pythagorean theorem. So let's go ahead and get back to this example. We have a right triangle here, and so I'm going to sketch it again. This is example 1 continued. So I'm going to redraw that triangle down here just so we can see it a little bit better. Okay, there's our right angle, and we know that this is 3, we know that this is 5, and this is what we're looking for, so I'll use a variable there. And the very first thing we need to do if we're going to use the Pythagorean theorem is identify the hypotenuse. And I just like to circle it so that I know what it is and I don't have to devote any more mental energy to it. So that's the hypotenuse because it's across from the right angle and it's the longest side. So when I use the Pythagorean theorem, I have to replace the C with 5. Other than that, A and B are interchangeable. So I'm going to go ahead and write down the Pythagorean theorem. A squared plus B squared equals C squared. And the 5 has to go where the C is because it's the hypotenuse. So A and B are going to be 3 and n, and it doesn't matter which one I put where. So 3 squared plus n squared equals 5 squared. And now we just simplify and solve. So 3 squared means 3 times 3. I'm going to drop this guy down. 5 squared means 5 times 5. And now this is just a regular two-step equation. I do have exponents, but I think you'll probably remember how to deal with that from algebra. So I'll subtract 9 from both sides. That drops. 25 minus 9 is 16. And so now what I have to do to get rid of a squared, the opposite of squared is square root. So I'm going to have to take the square root of the left and the square root of the right. So the square root of n squared is n. That's the whole point. The square root and the squared undo each other here. So we're left just with n. The equal sign drops. And then the square root of 16 means what number times itself is 16. So you might know it, you might not. I do want to show you how to do it on these calculators because I think that's important, just in case you're not dealing with one that works out to be a whole number. On my calculators, the square root button is right there. It's above the x squared. And so to access that, you hit second and then you hit that button and it'll bring up the square root. And then you just type in your number and it'll tell you the answer. So n equals 4. So going back up to our example here, the length of SP is 4. We're going to go ahead and turn the page and do our last example for today. So again, we have sort of a doozy of a figure. So I would like for you to draw a line segment. This time we'll make a vertical line segment. And we'll call this AC. And we're going to draw a perpendicular bisector of that line segment. So that means I need to locate the midpoint and then draw a line that hits that in a perpendicular way. So that purple line that I drew is a perpendicular bisector. And we can label that. This is a perpendicular bisector. Okay. And then we are going to draw point P somewhere off here. And remember, I'm not drawing to scale, so we're drawing a point. And we will connect that point to both endpoints. And then there's one more line that I want you to draw. We're also going to draw another line that goes through this point. So we're going to draw another bisector, but this time it's not going to be a perpendicular bisector. So we're just going to draw another line that goes through that midpoint. So take a moment, pause the video if you need to get that down. And then there are a couple of things that we need to label here. So first, we're going to say that this line segment here is 4 units long. That's AC, or A mystery, I guess, is 4 units long. This segment here is 6 units long. It's just like class. And then we're also going to label this angle. We're going to say that this angle is 30 degrees. So I know this is a lot to get down, and I know that if you didn't draw it big enough, it might be challenging, but do the very best you can to get this diagram down. There are 2 things that I want us to find. I want us to find right here the length of CP. And I also want us to find the measure of this angle. And so I'm just going to say that this is X degrees. So 2 things for us to find. First, what is the length of line segment CP? And then I also want to know what is the measure of that angle. So I think we'll probably start here with the measure of that angle just because that's way easier. What this problem is trying to get you to understand is that when you have a perpendicular bisector, 4 90-degree angles are formed. And so that means that this angle right here is a 90-degree angle. So it should be pretty trivial to figure out the value of X. These 2 angles are complementary. So if they add up to 90 and 30 is already taken up, then X is just going to be 90 take away 30, which is 60 degrees. So that's pretty trivial, pretty easy. This last one, the length of CP, is a little bit more challenging. And so what I want to do, I'm going to grab my highlighter. I want to see if we can figure out where there's a right triangle that might be helpful. So I'm going to highlight that segment that we're looking for, CP, and I'm looking for a right triangle, so a triangle with a 90-degree angle in it. And so this is the triangle that I'm looking for here. That right triangle. If we know 2 of the sides, then we can use the Pythagorean theorem to find the 3rd side. And so I know that this is 6 because that's labeled, but I also know this side here because this is a perpendicular bisector, which means that AC was cut in half. If this segment is 4, then this segment also has to be 4. And so I'm going to take just a quick second to redraw my triangle. I find that to be really helpful just because these diagrams get so busy. It's really important to have a new drawing where you can draw all the mainly what's important in this particular problem and try to ignore the rest. And so this is what we're looking for. First step is to identify the hypotenuse here. The hypotenuse is the longest side, and it's also across from the right angle. And so the side that I'm looking for is actually the hypotenuse. So when I use the Pythagorean theorem, a squared plus b squared equals c squared, I'm going to make sure that I leave c as a variable. That's the unknown. 4 and 6 are a and b, and those are interchangeable. So this one's a little bit easier than the last one. What I'd like you to do now is if you feel confident, I'd like you to try to solve this problem on your own. If you don't feel confident, you can follow along with me. So I'm going to replace the a with 4 and the b with 6. And I'm going to leave c as a variable because that's my unknown. 4 squared means 4 times 4. 6 squared means 6 times 6. And then I'm just going to type that in on my calculator. Feeling lazy. 16 plus 36 is 52. So there's nothing to solve yet. I'm not solving, I'm just simplifying this side, right? I'm getting it down to just one number since I can do that. And at this point, it's all I need to do to get c by itself is get rid of the squared. And the way we get rid of a squared is with a square root. So I'm going to square root the right and square root the left. 52 is not a perfect square, and so I'm going to need my calculator to find that answer. So square root of 52, and I know a lot of you are probably using your cell phone calculators, so just figure out how to do it. A lot of times you have to type the number first and then hit the square root button, so try that if it's not working out. But C is approximately equal to 7.21. I'm rounding to the nearest hundredth here, just because I decided to, for no other reason. So that's it. Today is really about how perpendicular bisectors create these right triangles and how to use the Pythagorean theorem to find missing lengths in right triangles. So for your summary today, that's definitely what I would focus on. I would focus on how perpendicular bisectors create right triangles and how when you're trying to find the missing side lengths of right triangles, you can use the Pythagorean theorem. So write your summary and you're done.